Hi, Assalamualaikum warahmatullahi wabarakatuh. Today, our group would like to present our topic, which is basic chromatography. Did you know what is basic chromatography? If you want to know and doesn't know anything about chromatography, so let's watch this video presentation. So, introductions. Chromatography is a powerful analytical technique employed to separate and identify components within a mixture based on their differential affinities for mobile and stationary phase. The fundamental principle involves the distribution of analytes between these phases, resulting in distinct migration rates. Gas chromatography GC, liquid chromatography LC, and thin layer chromatography TLC are common variants. GC utilizes a gaussian mobile phase, while LC employs a liquid mobile phase. TLC involves a stationary phase coated on a solid support. By exploiting diverse interactions such as adsorption, partition, or ion exchange, chromatography facilitates precise analysis of complex mixtures in various scientific fields, including chemistry, biology, and environmental science.
So, we move to the types of basic chromatography. So, we have three types of basic chromatography. The first one is thin layer chromatography TLC, gas chromatography GC, and also the liquid chromatography and also LC. For the thin layer chromatography TLC, a thin layer of an absorbent material such as silica, gel, or alumina is coated on a flat support, often a glass or plastic plate. The sample mixture is spotted near the bottom of the plate and is then allowed to migrate as a solvent. The mobile phase moves up the plate through capillary action. For gas chromatography, the mobile phase is a gas, often an inert carrier gas like helium, and the stationary phase is a liquid or solid coated on a column. And the last one, for liquid chromatography, involves the separation of components in the liquid mobile phase, moving through a column containing a stationary phase. And high performance liquid chromatography HPLC is a common type of liquid chromatography where the liquid mobile phase is forced through the column under high pressure.
Now we will go to the application of basic chromatography. So chromatography is a versatile separation technique used in a various fields for analyzing and purifying substances. So I have chosen three common applications of chromatography, which is the first one is analytical chemistry, the second one is pharmaceutical, and the third one is food industry. So for the first one, analytical chemistry is separate to a two sections. So the first one is qualitative analysis. Qualitative analysis is a chromatography that widely used to identify the components of a mixture. Each compound in a sample interact differently with the stationary phase, leading to separation. So for the quantitative analysis, it is a chromatography that can be used to determine the concentration of specific compound in a mixture by comparing peak areas or the liters. So for pharmaceutical, it has two sections too. So the first one is drug analysis. Chromatography is employed for analyzing pharmaceutical drugs to ensure they are purified and determine the concentration of active ingredients. So for the quality control, it is used in quality process during the manufacturing of pharmaceutical. And the last one is food industry. So for the food, it is a chromatography that utilized for detecting and quantifying food additive and preservative. For the second one, it helps in separating and identifying components in flavor and fragrance.
So now let's move to advantage and disadvantage of basic chromatography. So here is the advantage. First, separation of complex mixture Chromatography is highly effective in separating complex mixture of compounds. It exploits the different definitions of components for the stationary and mobile phase, allowing for distinct separation based on their unique chemical properties. So the second advantage is accurate substance identification. Chromatography is in precise identification of substance within a mixture. By comparing retention times or evolution patterns with no standards, researchers can confidently identify, quantify individual components. Third, high sensitivity. Chromatographic technique often provide high sensitivity, enabling the detection of trace amount of substance. This is crucial in analytical chemistry when dealing with samples of low concentration. Number 4 and last one, research and development application. Research and development application. Chromatography plays a crucial role in research and development across various industries, including pharmaceuticals, food and beverage, environmental monitoring, and more. It aids in optimizing processes, ensuring product quality, and complying with regulatory standards. So, now let's move to disadvantage of basic chromatography. First one is complexity of technique. Chromatography method can be intricate, requiring specialized equipment and expertise. This complexity can make the technique challenging for inexperienced user and may necessitate significant training. Number 2, limited sample loading. Depend on the type of chromatography, there may be limitation on the amount of sample that can be loaded onto the column. This can be a drawback when dealing with samples of very low concentration. So the third one is selectivity challenge. Achieving optimal separation of all components in a mixture can be challenging. Some compounds may have similar affinities for the stationary phase, leading to co-elution and difficulty in distinguishing them. Number 4 and last for disadvantage is time consuming. Depending on the method and the complexity of the separation, chromatography can be time consuming. Long analysis times may be a drawback in a situation where repeats results are essential.
Alright, for now I want to determine about how to separate blood, alcohol and blood in patients. But separating alcohol from blood is a medical procedure that should only be performed by a licensed medical professional. So separating alcohol from blood is a complex and risky process that should only be done by trained professionals in medical setting. If you have concern about alcohol in the bloodstream, it's crucial to consult with a healthcare professional for proper guidance and treatment options. Experimenting with such processes at home can have severe consequences and it's not advisable. Your well-being is important, so it's best to rely on the expertise of medical professionals in this situation.
So we move to determining alcohol level. There are 4 ways on how to determine the alcohol level. The first one is sample preparation, the second one instrument setup, the third one injection, and the last one is separation. And I'm going to explain for each this step. For sample preparation, to begin by preparing the sample. This may involve diluting the sample with an appropriate solvent to create a solution suitable for injection. For instrument setup, set up the gas chromatograph with a suitable column. Columns with polar stationary phase are often used for alcohol analysis. Calibrate the instrument using standard solutions of non-alcohol concentration. For the injection, inject the prepared sample into the gas chromatograph. The injected sample vaporized in the heated injector. And the last one is separation. The sample components travel through the chromatographic column based on their affinity for the stationary phase. The alcohol compounds will separate based on their boiling points and interaction with the column.
So now, we will go to the how to determine the blood level of patient bloodstream. So in order to determining the patient level of bloodstream, we have used two methods. So the first one is we have using the high performance liquid chromatography, which is HPLC, and the second one is gas chromatography. So what is a HPLC? HPLC is a powerful analytical technique used for the separation, identification, and quantification of component in a mixture. So what about gas chromatography? So gas chromatography, GC, is a chromatographic technique used for the separation and analysis of volatile compound. It is widely employed in analytical chemistry for a variety of applications, including qualitative and quantitative analysis of complex mixture.
Now I want to determine about the present and absent alcohol. Detecting alcohol in the bloodstream is typically done through blood alcohol concentration BAC testing. Common methods include breath test, blood test, and urine test. Breath tests are often used for quick and non-invasive screening. They measure the amount of alcohol in the brain, which correlates with the alcohol concentration in the blood. Blood tests directly measure the amount of alcohol in the blood and are considered more accurate. However, they require a blood sample and are more invasive. Urine tests can also indicate the presence of alcohol metabolites, but they are less commonly used for immediate detection due to a longer detection window. It's important to note that different methods have varying levels of accuracy and reliability. The choice of method depends on factors such as the specific requirements of situation and the available resources.
We have arrived at the last chapter, which is conclusion. In conclusion, chromatograph is a versatile and indispensable technique in analytical chemistry, providing a powerful means of separating and analyzing complex mixture. The three basic types of chromatography, the first one is thin layer chromatography, TLC, the second one gas chromatography, GC, and the last one is liquid chromatography, offer distinct advantage and applications. TLC is commonly employed for qualitative analysis and monitoring reactions, while GC excel in separating volatile compounds, make it ideal for applications such as forensic science. LC, particularly high-performance liquid chromatograph (HPLC), is widely utilized for diverse purposes, including the analysis of pharmaceuticals and biomolecules. So that's all from me.